Welcome back again. See, in this class, let us discuss about writing the given expressions in simplest form. So, the question says, write the following in the simplest form. See, I have considered 6 examples here. So, all these 6 examples carry 3 marks in part C. Okay. So, simplest, write the following in the simplest form. See, tan inverse of cos x divided by 1 minus sin x, cot inverse of 1 by square root of x square minus 1. Then this one is tan inverse of square root of 1 plus x square minus 1 by x. So here, what is the technique here is, so there are 2 points to remember here. So we use substitution method and we use some of the basic trigonometric properties to write them in simplest form. So out of these 6 examples, I will solve 2 examples in this class. So you concentrate what I am saying and what I am writing on the screen. So you write all the formulas which are needed separately and you substitute wherever the necessity arises. Okay. So out of these 6 problems, now let us see here, consider second one. I will solve second one. So it is cot inverse of 1 by square root of x square minus 1. So let us solve this second one. So the given expression is cot inverse of 1 by square root of x square minus 1. Okay, this is the expression. So here I am considering second problem, 1 by square root of x square minus 1. So that is cot inverse of 1 by square root of x square minus 1. See here, as I told earlier, I will continue by substitution method. So put x is equal to, see, my substitution is, instead of x, I will put secant theta. X is equal to secant theta to the numerator. Then I will go on simplifying this quantity. This is x square minus 1. See here, put x is equal to secant theta. So what happens to the denominator here? Under the square root, I have x square minus 1. So if I put x is equal to secant theta, that quantity becomes what? Secant square theta minus 1. So to simplify this, we can use the basic property. So the expression becomes cot inverse of 1 by square root of secant square theta minus 1. This is under square root. Okay. Now see here, secant square theta minus 1. So we know 1 plus tan square theta is equal to secant square theta. So this identity, this is a trigonometric identity. 1 plus tan square theta is equal to secant square theta. So here secant square theta minus 1 is there. So what it becomes? Tan square theta is equal to secant square theta minus 1. See, you shift this one to this side here. I get secant square theta minus 1. So instead of secant square theta minus 1, I can write what? Tan square theta in the next step. So I will do that in the next step. So that becomes cot inverse of 1 by square root of, see, that whole thing became tan square theta. So cot inverse of, see, 1 by, so square root of tan square theta means what? This is tan theta. So square root of tan square theta means tan theta. So this in the next step, 1 by tan theta means what? reciprocal of cot is tan. So 1 by tan theta can be written as cot theta. So cot inverse of, so I can write that as cot inverse of, so 1 by tan theta was there, so cot inverse of, so this will be what, cot theta. So cot inverse of cot theta is what, theta. So theta is, so what is theta? So we have substituted in the first step, we have substituted x is equal to secant theta. So theta is what, secant inverse x, secant inverse x. So theta is what, secant inverse x. So this is the simplified form of the given expression. See here, so cot inverse of 1 by square root of x square minus 1 was given. The simplified form for this is secant inverse x. So we can do like this. So this is the second example. So now see, I will consider this fourth one, 1 by square root of x square minus 1. See, both these are same, but outside here I have cot inverse, here I have tan inverse. Only difference is this is cot inverse and tan inverse. So I will go for fourth one. So the given expression is tan inverse of 1 by square root of x square minus 1. See, 1 by square root of x square minus. So as we done in the previous example, same substitution. Put x is equal to secant theta. Put x is equal to secant theta. So this is the important substitution to the denominator. Then here theta becomes what? Secant inverse x. You can write these two steps here. Then I will substitute it in the denominator. Okay. So that is tan inverse. See, tan inverse of 1 by square root of secant square theta minus 1. See, once again I can use the identity. So what was the identity? 1 plus tan square theta is equal to secant square theta, or tan square theta is equal to secant square theta minus 1. So I can do this one. So instead of secant square theta minus 1, I can write tan square theta. So that I will write it in the next step. So I will get tan inverse of 1 by square root of tan square theta. So that I will get tan inverse of 1 by, see, square root of tan square theta means what? Tan theta. So that I will get tan inverse of, so 1 by tan theta is what? See, cot theta. Tan inverse of cot theta. So now I cannot write this as theta because it is, observe here, these two are different. So tan inverse is outside and cot is inside. So let me consider this. So tan inverse of, see, cot theta, I got cot theta. So that is nothing but tan inverse of, see, this cot can be written as, see, tan of, so ratio should change. Ratio should change means what? I can use pi by 2 minus theta. So 90 minus theta, it lies in first quadrant, and ratio changes tan to cot. So tan of pi by 2 minus theta is as good as cot theta. So now I can write this as pi by 2 minus theta. So what is that? Pi by 2 minus, so this theta was secant inverse x. See, this is the simplified form of this example. Pi by 2 minus secant inverse. So you have to be careful in this step here. Tan of pi by 2 minus theta. So I get pi by 2 minus theta can be replaced as secant inverse x. Okay. So you write down the solution neatly. So we shall solve the remaining problems in the next video. So now we have solved this one. and this one. So these two are have been solved in this video. So let us consider some more problems in the next video. Okay.